My name is Philippe Delaert. I'm a product manager again for Fabric Services System. And I'm here today to talk about the cloud management system integration with the Nokia Fabric Services System. It's a mouthful. It's an interesting mouthful though. A Fabric Services System environment or a Fabric manager is great for your Fabric, right? You want to manage your Fabric from a central perspective. However, in a modern data center, you are running applications which are running on typically cloud management systems. And if you're running on cloud management systems, your applications are very agile. They can move around between hypervisors or computes. They can scale in, they can scale out. They need their network to be available at any time of that sequence, right? And again, with CI/CD that we were been talking about, you also have a lot of applications coming up, like test environments, et cetera, et cetera. So the Fabric needs to be very agile. The Fabric needs to respond to those application changes. And this ephemeral nature of the applications and of the cloud management systems requires a Fabric that can follow that, a Fabric that is in lockstep with the applications, that is evolving together with the applications at all time and making sure that your Fabric is configured in such a way that is optimally providing the connectivity for your applications. And the Fabric Services System makes that network agile. We bring in an integration with cloud management systems across the major ones like OpenStack, OpenShift, Kubernetes, VMware, vSphere. All of those we can support and more in the future as well, obviously. And we react to the changes in those cloud management systems and make sure that there is a performant and elastic configuration in that Fabric. And to do that, we have introduced a Connect service. A Connect, of course, obviously is playing on the name of connecting into a cloud. And the Connect service is designed to provide an easy and clean API that can be used by your cloud management systems and by plugins inside your cloud management system to connect into the Fabric Manager and to configure the Fabric Manager. We ourselves provide plugins, as I mentioned before, for OpenStack, VMware vSphere, and OpenShift, which native Kubernetes as well. And this API is extensible, so somebody else can build a plugin if they want to and use their own system, or if they don't like our OpenStack plugin, they want to build their own very specific one, go right ahead. That's what the API is for. We give you the information to do so. What's important with this Connect services and what these plugins are doing is they're listening to the events of your cloud management system. They're not making any changes in the cloud management system. We're just a listener. And for every change that is happening in the cloud management system, we take the right approach to facilitate that change in the Fabric. We make sure the Fabric is ready for whatever the CMS wants to do, right? And there's a few key aspects to this and how this works. One of the things that I want to highlight is that there is a topology database that we build ourselves. So we enable LLDP automatically on all of the SR Linux devices, and we're listening to the LLDP coming in from the compute hosts or from the servers or whatever compute stack you're using. That way, our system is aware which compute node is connected to which leaf port or edge link, as we call them in our system, and we can correlate events back to that. So whenever something happens on the CMS platform, and whenever an application is deployed on a compute node, we automatically figure out this application is connected to this network is this EVPN. Oh, this compute node is not yet connected in the network. So we need to change the Fabric to make sure it's connected. So we're listening to those events. And there's two ways of working with the Connect service and with the plugins typically. One is what we call a CMS managed mode or transparent mode. In that mode, the operator, the application owner, the administrator of your CMS can create networks, and we will reflect and create EVPN networks in the Fabric automatically. Those are isolated networks still, so even if the application manager is trying to do something fishy, it will be an isolated environment, right? It's not able to connect into anything else unless you, as a network administrator, have enabled more advanced use cases. So that's a really transparent mode, and from an application owner, you really don't see any difference from your day-to-day activity. The other solution that you have is a Fabric centralized managed mode. And that is where network administrators, application owners, whoever wants to control the network can go in to the Fabric Services System UI API, either as a user or an orchestrator, create network constructs, potentially with more advanced functionalities than a typical CMS would expose, and then expose those networks to the CMS. So as a network administrator, I could go in, create a complex structure of networks with routers and breakout configurations with BGP, PECE, quality of service, et cetera, then go to my CMS and say, there's an application network. This is the information you need to use from the Fabric Manager, and now you can connect applications into it. Still, Connect on its own will never provision a network on an SR Linux device until it is necessary. Even in that second way of working, the Fabric is aware of the networks, but it will not provision them on the SR Linux devices until it is really necessary for the application to use, right? And so this is what I'm going to try and demonstrate a little bit. We went from pure CLI to UI plus CLI. You can guess where this is going. We're going full UI now. There's not that much CLI to show in this case, so I probably am not a true networking demo, but it's still a pretty cool one. So I'm going to walk you through a VMware vSphere setup where I have a few hypervisors already present, where the Fabric already has a few networks available in overlay networks for the infrastructure, which are your management network, your infrastructure network, your storage network, et cetera. Those are being pre-configured in the Fabric. The CMS, in this case vCenter, is aware of those networks. If I connect anything into it, like a new compute, which is what I'll demonstrate, automatically that compute will be getting that network. The top of rack that is using this compute or is connected to this compute will get that configuration pushed down. So that is the Fabric centralized way of working. The other way of working, where you create application networks in your CMS, in this case, again, vCenter is also something I'll show, is what happens if I create a new network in vCenter, right? And similarly, the Fabric will seamlessly be automatically configured from that. Walk you through a little bit of my setup. I zoomed in. I hope the VPN works. Yes. I have one Fabric. It's even simpler than Fabric. I actually only have 2 nodes in my environment. So basically, 2 are interconnected for a top of rack simulating basically a multi-homed environment, right? Within this Fabric, there's again 2 devices here. 1 Fabric. I also mentioned that we already have a few networks available, right? So let's go down to my actual workload, VPN intents, and you can see that I have this infrastructure network available. Maybe I can zoom out a little bit, but anyway. So there we go. I have a bunch of networks pre-revisioned in this environment. And you can see that right now there's 6 subnets defined, and one of my subnets is an edge case network where I've configured BGP, PECE, things like that are available. I have a storage network for my hypervisors to reach out to any type of iSCSI storage or things like that. And then a VMware infrastructure network, which you could use for what is it, vMotion, vSAN, all of those kind of nifty features VMware offers you. Bringing back to my VMware environment, I can also go here. I probably do have to refresh my page. And you can see that sometimes refreshing is not enough. There we go. Got 2 hypervisors already provisioned. Ignore the red icon. My hypervisors are very simplistic servers with 2 interfaces, so I only have 1 interface on my management network. It's complaining about redundancy. Ignore that. But yeah, I've got 2 hypervisors configured, and you can also see that I have a DV switch configured, which is kind of matching with what I have in my Fabric Manager, right? Looking at the topology of that, you could, probably should. Yep. The topology is very simple. I have a few VM kernel ports, and I have these interfaces in here, and I have all of these networks. Going back to the networks, I mentioned that if you're working with a Fabric managed solution or networking, you need to make the CMS aware of what network is going to be used for each of these port groups in vCenter or Neutron networks in OpenStack, et cetera. So if you look at the information here, you can see that there's a custom attribute where you can fill in an ID that is matching the ID in your Fabric. The same thing happens within your management network. You have a subnet ID that matches with the exact ID of the management network that I created in my fabric. So this is how the system knows that these are related to each other. And in the background, my plugin is already working. It's already doing its thing, and I can show you that with something that Erwin alluded to, but didn't really go into too much detail, giving me the opportunity, and that's labels, right? So what we do is we use labels in the Fabric Services system extensively. And labels are things you can use to, well, label things, obviously, but you can link things and use those labels to then connect them into subnets, to label devices and do a maintenance, for instance. If you want to say, I have 10 racks, each of them have 2 devices, and I want to label my first one as main and my second one as backup, just a name, and then you want to do a maintenance intent on your main label, only the first one of each top of rack will be, or pair of top of racks, will be upgraded or maintained. So you can do easy maintenance on that way, and labels are used across the system everywhere as an easy way to manage everything. So in this case, you can see at the bottom that I have edge link labels. And these are clearly the ones that are coming from my DV switch in VMware. It's an uplink for the first one for my DV switch, and then a second uplink. And if you look at these labels, my plugin already identified that these 2 edge links, these 2 ports are in use. And for ease of use in my lab, hypervisor 2 is on Ethernet 1.2, hypervisor 3 is on Ethernet 1.3, always. Makes it easier to correlate. So you can see that the plugin has pushed this inside those labels. And then if you go to the workload intent itself, and you check where we're talking about the networks, and I go into just one of the networks, really doesn't matter that much, you'll see that if we're looking at the sub interfaces, there's already a bunch created, or 2 in this case are created, which have been auto-generated from that label. So we did not add specific Ethernet ports into the subnet as sub interfaces. We just said everything that's labeled with this label needs to be a sub interface, and with a specific VLAN in this case as well, so VLAN ID 300.
And it discovered that VLAN from the VMware assignment?
In this case, I created the VLAN because I was the one that this is the Fabric managed environment, right? Or the Fabric managed approach, where I pre-create the network in the Fabric and then I expose it into the cloud management system. So I defined the VLAN in this case. However, when we go later on in the demo to the centralized or VMware-centered managed solution, you will see that we indeed determine the VLAN based on what the configuration is from the port group in VMware. Yeah. So the next thing is, let's just bring in a new hypervisor, right? It's kind of important that we can do this from a networking perspective, be able to dynamically discover new connectivity that is needed for your applications or even your infrastructure. So it's loading the hypervisor. It takes a couple of seconds, 10, 20 seconds to load this in. While it's doing that, one important thing to note is when we're talking about DV switches, I mentioned that the way that the connect service knows which port to connect into which network is by using LLDP to discover the relationship between edge or edge link and hypervisors. So important is that this setting for LLDP is always configured to either advertise at least or both in this case, because I'd like to have both enabled. By now, my hypervisor should be here. Nothing has changed yet because the hypervisor is not connected into my managed network, right? It's not connected into my network that is managed by the Fabric. But if I add this into this port group, and I'll just add one of my uplinks into this, and I'll even move my management interface into this environment. There we go. Let's give it a couple of seconds to finish that, although pretty quickly it's done. Let's see what happens in the Fabric, right? This could take a few seconds because, again, LLDP needs to happen and LLDP needs to send its messages. But ideally, if I show the assignments to the label now, my plugin has told my service, if you see this compute information, add that port with that information into your label. So as you can see now, port 14 is immediately added into my network, right? And you can also see that normally, if I go to my workload VPN intents, you will see that in the subnets, any subnet, you should be seeing that there's a new port added as well, automatically generated. That is also immediately deployed into your fabric. So I didn't really show this with a ping. I should have probably showed a ping because then I could have shown CLI. Damn it.
Game, friendo.
Such a chance missed. What I could have shown is that the ping to my hypervisor's management interface didn't really go down at all, right? It's immediately picking up that change and immediately pushing it down to the fabric and making sure the connectivity is guaranteed for your management interface. Let's move on to the centralized or the vCenter managed solution or the CMS managed solution, right? So in this case, this DV switch was created by my fabric manager first and then imported or used into vCenter using those IDs. What I can do now in the same environment is create a new DV switch. So I can call this DVS app 01. Keep things simple. I'm not going to create a default port group for now, because the first thing I want to do is enable LLDP. Actually. And so we go to LLDP settings. We make sure that this is configured to at least advertise. And right now, there's no hypervisors yet, as you know, right? Nothing is connected into this yet. However, again, with the plugin running, you should see that new labels have been created for that application DV switch. Right? They're going to be empty because there's no hypervisors connected to it, but they're ready for use, right? So let's now add a few hypervisors to this. Let's just do all three of them. And let's use the second interface for this. And hopefully all of that should be configured quickly according to vCenter. Let's see what my labels have done. And not yet. LLDP takes some time, I guess. It should come in time, and if not, then the demo gods have not been friendly to me.
I mean, you crash ping, you gotta have some really bad luck there.
That's
It's
supposed to be hard to beat. Yeah.
Going to verify that LLDP, isn't it?
you don't challenge them.
Did I select the right label though? Well, something's happening for sure. Oh, I was looking at the wrong label. There we go. This is the right label. Apologies for that. So let's go back to the labels and actually show you. The reason I switched up is because I was selecting the first one, which says uplink number 2. And I added my interfaces to uplink number 1. So I should have looked at like sorting the labels properly based on the description or the comment. I can remove something and show you that something gets removed if you want to trust me.
Oh, I'm sure it was intentional.
Okay, cool.
You just wanted to show us that
Yeah.
it correctly looks for that label.
So what happens if I create a network now? Because it's, of course, the hypervisors are not doing anything yet. There's no networks. If you look at the workload intents, you will see that there is a kind of weirdly named workload intent granted, but there's no subnets there yet, right? Because we didn't create any port groups yet. So let me create a port group here. Just call it, and we'll call that the front end, and we'll make that VLAN. Any preferences? Nothing. Okay, cool. Just use 1000. You will see that if everything goes right, actually you can see the change happening. The UI is a little flaky, but you can see the change happening and the version changed. So that means something happened, something got deployed. And if you go to your subnets, you can now see that there's a new subnet here that is coming from VLAN 100, well, 1000. And if you go into the subnet again and look at the sub interfaces, you will see the description being empty, which is something we need to fix. You'll see these 3 interfaces added based on the label and with VLAN ID 1000. Okay? So this is the way that you can either give your application owner some control in creating their networks, or you can have a more centralized way of working with your networks and have it from a central management perspective. Either way are fine. You can mix and match. We're also going to be able to disable a certain mode. Like for instance, if you really want only Fabric managed networks, you could potentially configure the plugin in such a way to not allow the CMS managed networks to come up, right? To log that if you want to.